far from shore. A dead whale drifts at the surface of the ocean. Its enormous body rises and falls with the waves, surrounded by seabirds and carried slowly by the current. For humans, the carcass may appear tragic and lifeless, but in the ocean, death on this scale creates an extraordinary source of energy. Oils, blood, and other chemical signals spread through the water. Scavenging birds gather above it. Fish approach from below. Then, one after another, dark shapes begin appearing in the surrounding blue. Great white sharks have found the carcass. Some are young, others are massive adults, more than 5 meters long. Under normal circumstances, these predators travel independently and compete for valuable food. Yet around the body of a whale, several great whites may feed at the same time with surprisingly little serious aggression. They bump against one another, pass within biting distance, and remove enormous pieces of flesh from the same carcass. For a brief period, the ocean's most feared solitary hunters appear to accept an uneasy truce. A whale carcass is unlike almost any other meal available to a great white shark. Hunting a living seal requires speed, timing, and risk. The shark must locate the animal, approach without being detected, accelerate, and deliver a disabling bite before the seal can escape. A missed attack wastes energy. A struggling seal may bite, turn sharply, or injure the shark's eyes and gills. Even a successful hunt may provide only one meal. A whale carcass presents a completely different problem. The prey cannot escape. It cannot fight back. Its body contains many tons of muscle, organs, and energy-rich fat. One shark could feed repeatedly and still leave enough food for many others. The carcass is so large that defending the entire resource would be almost impossible and probably unnecessary. When food is limited, competition becomes intense because one animal's success removes the opportunity from another. When the resource is enormous, several predators can feed without immediately reducing one another's reward. Fighting becomes less valuable. A great white injured while defending part of a whale might lose far more than it gains. The smarter strategy is often tolerance. This does not mean the sharks become peaceful friends. They remain powerful competitors capable of injuring one another, but they appear to manage their spacing, approach angles, and feeding positions in ways that reduce unnecessary conflict. Larger sharks may move directly toward the carcass, while smaller individuals remain farther away or wait for pieces of tissue to drift free. Size itself can communicate priority without requiring a bite. A smaller shark does not need to test whether a 6-meter female is stronger. The difference is visible by moving aside. The smaller animal avoids injury and may still obtain food later. The larger shark gains access without spending energy in combat. Both animals benefit from understanding the situation before violence begins. The feeding behavior also reveals that great whites do not consume every part of a whale equally. They appear capable of selecting tissues according to nutritional value and ease of removal. Blubber is especially important. This thick layer of fat helps living whales conserve heat. But after death, it becomes an extremely concentrated source of energy. A large shark can bite into the carcass, clamp its jaws around a section of tissue, and shake its head from side to side. The serrated teeth function like saw blades, cutting through skin and fat. The shark then tears away a large piece and swallows it or moves away from the carcass before returning for another bite. The feeding motion differs from the violent strike used against living prey. When attacking a seal, the shark may approach rapidly and bite under conditions where the target is struggling and unpredictable. The eyes are vulnerable, and the shark may rotate them or protect them during close contact. At a whale carcass, the food does not suddenly turn and attack. The shark can feed more slowly, position its jaws carefully, and remove flesh with controlled lateral head movements. Researchers observing white sharks at whale carcasses have reported sharks biting, rejecting, or regurgitating certain pieces before feeding again. This behavior suggests that the animals may be evaluating the tissue inside their mouths. A piece containing too much tough skin, connective tissue, or low-value material may not be worth swallowing when richer fat remains available. A shark has no hands with which to examine food. Its mouth is both a weapon and an important sensory structure. By biting, holding, and manipulating tissue, it can gather information about texture and quality. What appears to be wasteful feeding may actually be selectivity. The shark rejects one piece because a better one can be obtained with the next bite. This is an important correction to the popular image of great whites as animals that swallow anything placed in front of them. A carcass may contain nearly unlimited food, yet the sharks still make choices. They search for locations where the skin has opened, where blubber can be removed efficiently, or where internal tissue has become accessible. The carcass changes over time. During the first day, much of the body may remain intact. Thick skin makes feeding difficult, and sharks concentrate on wounds, natural openings, or softer areas. As more animals bite, sections of skin are removed, and the interior becomes easier to reach. The work of one shark creates feeding opportunities for the next. Currents and decomposition also transform the carcass. Gases can keep the body floating, while waves rotate it and expose different surfaces. Oils spread across the water. Pieces of tissue break free and drift below, providing food for smaller sharks and other scavengers that cannot compete for direct access. A large female may feed at the carcass itself. A juvenile can remain beneath it, waiting for scraps. The animals occupy different positions according to size, confidence, and opportunity. In this way, competition is reduced without requiring formal cooperation. Several sharks may circle the whale before approaching. They gather information about which individuals are present and which section of the carcass is accessible. One shark moves in, bites, and withdraws. Another takes its place. At other times, multiple sharks feed simultaneously, separated by only a few meters. Their bodies may touch. One tail passes across another shark's head. A turning animal collides with a companion focused on the carcass. These moments could easily trigger an attack, yet serious aggression is often limited. The abundance of food appears to change the value of conflict. During one observation, sharks feeding close together tolerated contact that might have produced a stronger response in another situation. An accidental bite can still occur when an animal's head is hidden against the carcass and another shark enters the same space. But even an injury does not necessarily begin a prolonged fight. The sharks can separate and return to the resource. The carcass becomes a temporary gathering site where normal distances shrink. Individuals that might otherwise remain widely separated are drawn into the same small area by chemical signals and the movements of other scavengers. A great white may first detect a carcass through scent. Water carries molecules away from the whale, creating a chemical trail that can extend across the surrounding sea. The shark does not smell a single narrow line leading directly toward the food. Currents break the signal into patches. The animal must move through the water, repeatedly detecting and losing the scent while adjusting its direction. Birds and other sharks provide additional information. Seabirds gathering in one location indicate activity at the surface. A great white traveling in the distance may detect the movement of another shark and investigate. One predator's discovery unintentionally reveals the resource to others. As more sharks arrive, the carcass becomes the center of a temporary social network. Individuals observe who is feeding, who is dominant, and where access remains possible. They do not need to communicate with vocal signals. Body size, direction, speed, posture, and willingness to approach all provide information. A large shark moving steadily toward the carcass may cause another to yield. A smaller individual approaching cautiously communicates a lower level of challenge. Parallel swimming allows two animals to evaluate one another without immediately colliding. A sudden turn may signal that personal space has been crossed. This body language allows the sharks to settle many disputes before teeth become necessary. Direct combat between large predators is extremely dangerous. A single bite could damage the tail, remove part of a fin, or injure muscles essential for swimming, because sharks must keep moving water across their gills. An injury that reduces movement can become fatal. Natural selection therefore favors animals capable of recognizing when a confrontation is not worth the risk. The presence of food does not automatically produce a feeding frenzy. In many cases, the sharks remain deliberate and controlled. The phrase feeding frenzy suggests that predators lose awareness and bite without discrimination. Observations at whale carcasses reveal something more complex. The sharks continue monitoring their surroundings. They respond to larger individuals, choose particular tissues, adjust their position, and sometimes stop feeding even while food remains available. A shark can become temporarily full after consuming large quantities of blubber. Its movement may slow. An animal that approached the carcass aggressively may later appear heavy and less active. Instead of continuing to tear away flesh, it may swim slowly nearby or mouth the carcass without successfully removing another piece. Blubber offers enormous energy, but digesting it also takes time. A great white can consume a large meal and then survive for an extended period without feeding again. There is no benefit in taking more food than the body can process. This produces a changing pattern throughout the day. Hungry sharks arrive and feed intensely. Others become satisfied and move outward, creating space for new arrivals. The gathering is never completely stable. Individuals approach, feed, withdraw, and return. The largest sharks may receive special benefits from whale carcasses. As great whites grow, their hunting abilities and energy requirements change. A very large adult is powerful, but it may be less agile than a younger shark when chasing quick-turning seals. Its massive body requires high-energy food, yet every rapid pursuit becomes expensive. A dead whale provides exactly the kind of resource such an animal can exploit. The shark does not need to match the agility of living prey. It can obtain huge quantities of fat with relatively little danger or acceleration. This may explain why unusually large great whites are sometimes observed around whale carcasses. For an older shark, scavenging is not an inferior form of feeding. It may be one of the most efficient strategies available. Predators do not receive a greater biological reward for killing their own prey. Energy taken from a carcass is as valuable as energy taken from a living seal. The distinction between predator and scavenger is often created by human imagination. We celebrate the dramatic ambush and overlook the quiet meal. In reality, many successful carnivores use both strategies. Hunting provides food when vulnerable prey is available. Scavenging provides food when another animal's death creates an opportunity. Great whites can shift between these roles. Near Seal Island, one may spend the morning attempting to ambush seals from below. Later, the chemical trail from a dead whale can draw the same shark away from the hunting area. Why risk repeated attacks on agile prey when many tons of energy are already floating nearby? The presence of a whale carcass can therefore change shark behavior across a larger region. Sharks that normally patrol seal routes may leave those locations and gather around the dead animal. Predatory pressure on the seals temporarily decreases. A single carcass changes the distribution of multiple predators. The gathering can also reveal sharks that researchers rarely observe in ordinary coastal hunting areas. Large adults, transient individuals, and sharks following different movement patterns may all arrive at the same resource. The carcass becomes an unexpected research platform, allowing scientists to record size differences, social interactions, feeding preferences, and identification markings. Yet these events are difficult to predict. A whale may die far offshore, sink before being discovered, or drift into inaccessible water. Many carcasses never reach the coast and are never seen by humans. The observations available to science represent only a small fraction of the encounters occurring across the ocean. Some whale bodies sink to the seafloor, creating deep-sea ecosystems known as whale falls. Others remain at the surface long enough to support sharks, birds, fish, and marine mammals. Whether the body floats or sinks depends on the condition of the whale. Decomposition, depth, temperature, currents, and gases within the carcass. For a surface-feeding great white, timing matters. The shark must find the whale while valuable tissue remains accessible. As decomposition progresses and scavengers remove material, the carcass loses buoyancy. Eventually, it may sink beyond the shark's normal feeding depth, carrying the remaining energy toward the seafloor. Until that moment, the whale functions like an island. It attracts animals that would otherwise be scattered across many kilometers. Species meet that may rarely share the same space. Competition, tolerance, and feeding behavior become concentrated around one body. Human activity has altered the frequency of these opportunities. Historical whaling removed enormous numbers of large whales from the ocean. Each lost whale represented not only an individual animal, but also a future carcass that could have supplied energy to surface scavengers and deep-sea communities. As whale populations recover in some regions, more carcasses may again enter marine food webs naturally. This does not make the death of an individual unimportant. It shows that even after life ends, a whale continues supporting the ecosystem. A single carcass can feed great whites for days. The energy stored by the whale during years of feeding is transferred into sharks, birds, fish, bacteria, and eventually deep-sea organisms. nothing is wasted. Death becomes a biological event, extending far beyond the animal that died. For the great white, the encounter is a rare opportunity to feed without performing the dangerous hunt for which it is famous. But the easy meal creates a different challenge, sharing space with other apex predators. The sharks solve this problem not through friendship, but through calculation. There is enough food. Fighting is dangerous. Size can establish priority. Smaller animals can wait. Rich tissue can be selected. The entire carcass cannot be controlled by one individual. The result resembles a truce, but it is a truce created by economics. Violence becomes unnecessary because the reward is too large to defend and the cost of injury remains high. Somewhere in False Bay, a whale carcass drifts beneath a grey sky. A large female great white approaches from below. She rises beside the body, turns her head, and bites deeply into the blubber. Her jaws close, and she shakes from side to side until a heavy piece separates. Another shark waits only a few meters away. It does not rush toward her. It circles while she swallows and moves aside. A smaller shark feeds on loose tissue drifting below. Two others approach the opposite end of the whale. Their bodies briefly touch as both turn toward an opening in the skin. But neither begins an attack. For hours, the sharks continue feeding. Position change. Large individuals move closer. Smaller animals remain at the edges. The surface becomes covered with oil, feathers, and pieces of flesh. There is blood in the water, but no blind frenzy. Each shark remains aware of the others. Every approach is measured. Every bite is directed toward the carcass rather than the nearest moving body. The predators are feeding together because, for this brief period, tolerance provides a greater reward than violence. Eventually, the largest sharks become slower. Their stomachs are filled with energy-rich tissue, one after another. They leave the immediate area and disappear into deeper water. The carcass remains, still large enough to support new arrivals. From above, the gathering may look like a scene of chaos, massive sharks circling a dead whale, birds screaming, and pieces of flesh disappearing beneath the surface. But beneath that, violence exists, a hidden order. The sharks evaluate size. They choose positions. They avoid unnecessary wounds. They select the richest tissues and allow competitors to feed when defending the resource would cost too much. This is the Whale-Carcass Truce. It does not reveal that great whites are gentle, generous, or cooperative. It reveals something more useful for survival. They are flexible. A great white can become an explosive ambush predator when hunting a seal. It can become a cautious social competitor when feeding beside other sharks. It can attack, wait, withdraw, or tolerate according to the situation. The carcass does not remove competition. It changes the calculation behind it. When prey is alive and limited, speed decides who eats. When a whale dies and creates many tons of food, restraint can become the better strategy. The ocean's most feared predator does not survive by attacking everything around it. It survives by understanding when an attack is necessary and when sharing the same dead giant is safer than fighting over it.